So this time around, we are going to be looking at our next outcome in shape and space. Determine the surface area of a composite 3D object to solve problems. So let's break down the terminology there. Surface area should be familiar. It's the area of the visible surfaces. And a composite 3D object is an object that is made from other 3D objects. So let's take a quick look at this one. 9 shape and space. And this is outcome 2. So let's imagine that what you're looking at is 2 cubes stacked together. So if we had 2 cubes just normally, the surface area would be 6 times the length of each side squared. So if each side was of length x, then each face would have an area of x squared, and there's 6 faces, front, back, right, left, top, and bottom. So each of these 6 faces has an area of x squared. That would be 6x squared. But now if we take a second cube and slide it over to smash them together, we no longer have a 6x squared area. Even though each of those cubes has an area that's 6x squared, now not all of the surfaces are visible. Right? That's a big piece of this. In order to count as part of the surface area, we have to be able to see that surface. So we can't see the 12 surfaces we had before. We still have the one in front. Number 2 is in the rear. Number 3 would be here. We can't see surface number 3. We can still see 4, 5, and we can still see 6. In the next cube, we can see 7. We could see 8 in the rear. We could see 9 on this side, but 10 would be here as well. Surface 10 is touching surface 3. They are in contact with each other, making neither visible. So in our 12 surfaces, we only have 10 x squareds. So that is the key to looking at the surface area of composite objects. It's the surface area of all of the objects. If they were just loose and on their own, and then you have to subtract the blocked surfaces. So the surfaces that are in contact with other surfaces. That is going to be the key. So if we had, as another example, a grain silo. A grain silo could be approximated by saying, well, we have a cylinder, which we've drawn here. And then there's a cone on top. And what that will do is block this circular surface. So we don't get that surface area from the top of the silo or from the bottom of the cone. In both of those cases, that surface is no longer visible. So what we actually see is just that cone. So we have quote-unquote lost the top of the cylinder and the bottom of the cone. So that is key to finding the total surface area of composite 3D shapes. You have to find the surfaces that are in contact with each other and subtract them away.